30-minute kind of a little tip and trick kind of thing to get you a little bit of adrenaline in the morning for SolidWorks. So on your control panel, some of you guys are already using it. You're hopefully logged in. At the end, we'll open up the question and answer pane. And so if you type in some of the questions, and we'll take a look at those and answer them. All right, so plastics make your modern life possible. So can you imagine if everything that you depend on in life made of plastic suddenly disappeared? So your cell phones, some of the things that you drink out of, your DVDs and CDs, any of the piping, so the water systems, as dispensers. I mean, that would be horrible. And you know, helmets, things that protect you, and cars. And for the most part, the majority of those parts are made out of plastics. So SolidWorks Plastics gives you some flexibility and adaptivity that enables you to make your world better, safe, and of course more fun. So I've got a couple little fast facts on plastics, just to kind of keep you awake. The plastics industry is the 3rd largest manufacturing industry in the U.S. If you take your plastic water bottles and you freeze them, it does not release dioxins into your water, so that's a good thing to know. Recycled plastics are used to produce new products like lumber for your outdoor decking, carpeting, fleece jackets, and t-shirts. So every ton of plastic bottles recycled saves about 3.8 barrels of oil. So 2,000 tons of plastic is about 3.8 barrels. Pretty good. All right, and plastics are everywhere. They're just about, you look around, you're going to see plastic. If you're using a computer or a mouse, you're there. I also got this nice little iPhone 3GS, inauguration of the iPhone 3 that's coming out. I thought that'd be a pretty funny pic. Any of your iPhones or other cell phones, of course, use plastics. So here's some unanswered questions when you're dealing with plastics. Is it manufacturable? Can you actually make it out of plastic? Can you do an injection mold process? What's the best gate location? Unless you're a seasoned veteran in plastics or mold design, you may not know that best gate location. You may just be guessing. Where are the weld lines and the air traps? So what's a better way to design the mold that you're creating? How many mold revisions do you do? You do 5 or 10, or do you get lucky and make it in 2? So what about the cost of a change? Whenever you do a mold revision, how much does that cost? And how about the customer rejection due to visual structural defects? So again, kind of remaking the mold. A lot of times you'll do remakes on it, make sure that it's a little bit better, make sure that the mold lines up, you have good weld lines, things like that. So that also kind of goes into the quality of the product. And how can you innovate? How can you make it a little bit better? Can you use different processes to do a hot injection mold process versus just a gate? So some of our validation products for plastics, this is kind of I want to do a brief overview. We'll go into this a little bit more in detail later. But we have 3 different versions of plastics. We have a professional version, which mainly does surface and solid mesh. That's actually in all of them. All the weld lines, sink marks, air traps, multiple gates. When you get up to the plastics premium, then we get into multi-cavity. We can do runner balancing, co-injection processes, any types of overmold, shrinkage, cooling times. So this is the one that we try and get most people into. It's got a lot more tools for what you're going to be seeing. And then, of course, we have an advanced package that just came out last year, which includes warping, which has to do with the stress on the part after it's being cooled. And, of course, advanced cooling analysis. So where do you actually put some of your cooling bubblers and things into the actual mold? So I've got a kind of a customer, Hioki, and they make some medical equipment or electrical equipment, and you can see they've got a lot of little plastic parts that they have to deal with. And so some of their key challenges were islands of the automation. Some of their cycle times were very long and expensive. They needed to improve their manufacturing efficiency for the most part. So I've got a little electrical strip. This is kind of the little demo that we're going to be dealing with. And for the most part, we're going to deal with a couple different little scenarios. What-if scenarios on this. We'll look at multi-cavity molds, families of molds. So these are just kind of overall things that you can do once you get the simulation product. We can simulate the entire injection mold cycle times, how long it takes to inject, how long it takes to eject the mold, how long it takes to cool the mold, and so forth. And then we can also, of course, do advanced analysis over molding and things like that, inserts. All right, so getting a little window into your mold. This is the regular simulation workflow. So we have to mesh the part. After we mesh it, then we're going to do a setup. We have to tell it what the actual material is. In this case, we're going to use a generic ABS. After we do the ABS, we need to tell it where the ejection location is. We can have that automatically done, or we can just select the point on one of the nodes from the mesh. And then we're going to solve it. And once we solve it, then we can actually see how the actual part is being filled up. So pretty simple. And then there's a little review process. We have a lot of different options depending on what types of results you want. So maybe the actual flow time, how long it takes to fill it. If there's any air traps, then we'll have to alleviate that air through the mold. And then, of course, as the mold or the plastic flows around buttons and things like that, where the plastic is coming together and it's starting to cool, it can create weld lines. So you want to make sure that these weld lines are on the backs of the surfaces so they're not on the show surface of the part so that customers don't see that. So you try and eliminate those or move them, add a little bit more plastic or remove plastic to make sure that it looks right. So then we have some pressure plots. We can tell what the pressure is after injection, after cooling, if there's any shrinkage on the part, if there's any sink marks. So again, you got to watch out for the customers. They're gonna look for these things. They want to make sure there's no blemishes or anything on it, and all the show surfaces are perfect. And then we can also look at, of course, cooling time. How long does it take to get that out of there? The more parts we can produce in the less amount of time, that's going to increase your production. So we also have some really in-depth things that we can do. We can select on different points on the part, and we can find out what the actual nodal pressures are on those parts, or on those points. So I'm going to go right into the demo. This shouldn't take too long. Go right into SolidWorks. So I've got a little plastic part. If any of you have gone through the SolidWorks Essentials, then you'll probably notice this guy. And so I've got a little bit of work, a little bit of modeling work that I need to do in SolidWorks. So I'm going to just go to the features, and we're going to add